Today we are going to be looking at savings accounts. So one reason people open savings accounts is to keep their money safe. Another reason is so they can earn interest on their money. So this interest is like having free money added to the amount that you already have in your bank account. The longer you have your money in the bank, the more interest it's going to make. And the amount of interest always depends on the bank, the type of account, how long it's been there. So, banks and financial institutes typically have several different kinds of savings accounts. The interest might be figured semi-annually, quarterly, monthly, or daily. So, we need to know some of those terminologies and what they mean. Annually. Annually means it happens one time per year. Semi-annually is 2 times per year. Quarterly is 4 times per year. Monthly, there's 12 months in a year. And daily, we do 365 times per year. So, the interest formula we are going to use is that simple interest that we were calculating earlier in the unit. So your interest, which we call I, is equal to P times R times T. P is your principal, R is your rate, and T is your time. So let's look at our first example. Find the interest for 6 months on $400.60 at 1.5% annual interest paid semi-annually. So the key here is paid semi-annually. And semi-annually means twice per year. So 2 times per year. So we are going to use our formula. I equals PRT. Our principal is $400.60 times our rate. Our rate here is 1.5%, but we have to change the percent to a decimal. So remove the decimal 2 places to the left so it becomes 0.015. Times our time. It's happening semi-annually. Find the interest for 6 months. So that's half of a year. So it's going to be 1 times for semi-annually. So it's going to be 1/2. Now, we need to calculate this. So we are going to take 0.15 times it by 1/2. When we do that, we get 0.0075, and we're going to multiply that by our 400.6. And when we do that, we get 3.0045. But we are talking about money. So, money, we have our tens and our ones. So we need to round. So when we're rounding, we are going to drop off because the digit behind is not high enough to raise. So we earn $3 in 6 months. Let's look at the next problem. What interest is paid for 3 months on $860 at 2.25% annual interest paid quarterly. So every 3 months is 1/4. So we're using the same formula. I equals PRT. Our principal, $860, times our rate, 2.25, changed to a decimal is 0.0225. Then we're going to multiply it by our time, and it's quarterly, so that's 4 times. And we're talking about 1/4, so just going to multiply it by 1/4. So we're going to take our rate for the decimal, 0.0225, and multiply it by 1/4. And we get 0.005625. We're going to take that and multiply it by 860, and we get 4.8375. Now we have to round this. We're rounding to the ones place, so the 7 tells us we have to round up. So we're going to have $4.84. And that is going to be paid every 3 months. Okay, now let's look at compound. So, some do compounded interest. So, anytime you see the words compounded, you are going to be using this formula. Same formula that we had before, but now we are involving the component n. So, n is for many times interest is compounded per year. So if it's compounded quarterly, your n would be 4. Same with up here. If it's compounded semi-annually, your n would be 2. So we're just changing our compounded interest formula, which we had a equals p times 1 plus r to the t, and we're adding in the n component. So we're going to take the rate and divide it by the number of times it's compounded per year, and then raising that added to 1 to the t times the number of times it's compounded. So let's look at an example and hopefully put this all together. So, example 3. Find the compound interest paid on a $400 deposit that earns interest at an annual rate of 2%, compounded quarterly for 10 years. So, compounded quarterly. When you see the words compounded quarterly, you're going to be using this formula. And we're going to be using, for quarters, 4. So our n equals 4. $400 is our principal. Has an interest rate of 2%. 2% change to a decimal is 0.02. And our time is 10 years. So we're going to have A equals our principal, $400, plus $400 times 1 plus our rate, 0.02, divided by our n, how many times it's compounded. So divide by 4 to the 4 times our time, 10. First thing you want to simplify is this exponent. 4 times 10 gives us 40. So we're going to be raising it to the 40th power. Now divide 0.02 divided by 4 gives us 0.005. We're adding a 1 to it, so it'd be 1.005 times 400. Now, in your calculator, do 400 parentheses 1.005 end your parentheses, do the caret to use your exponent, and type in 40. When you do this, you will be getting 488.3176, and it continues on. We are rounding. We're talking about money. So we have $488. We need the ones digit. We look behind, we're rounding up. So 32 cents. So that's how much will be in the bank account after 10 years. So it started off with $400 and ending with $488.32. Now it's asking us to find the difference between those two amounts. So start with your compounded amount. We're going to subtract the original amount. When we subtract that, we get $88.32 that you earned in interest in those 10 years. Let's look at another example. What compound interest is paid on a $1,100 deposit earning 3% interest compounded semi-annually for 3 years? Okay, let's start with our formula. A equals P times 1 plus R divided by N raised to the N times T. So our principal is $1,100 times 1 plus our rate, 3% changed to a decimal, 0.03, compounded semi-annually. Semi-annually means 2 times per year. So we're going to divide it by 2. Then we're going to raise it to the 2, because it's compounded semi-annually, times the number of years, 3 years. Now we need to calculate this. Please make sure you're doing it in the same steps I am. So when you type this on your calculator one step, you do not enter it incorrectly. So start with your exponent. 2 times 3 gives you 6. So we're going to raise it to the 6th power. Now we're going to calculate 0.03 divided by 2. And we get 0.015. We're adding 1 to 0.015, so all it does is bring down the 1. And then multiply it by 1,100. Now in your calculator, do 1,100 parentheses 1.015, end your parentheses, hit the caret to raise it to the 6th power. And you get $1,202.79 when it's rounded. The last problem we're going to look at today is dealing with interest that is compounded daily. So, a $1,200 deposit earns annual interest of 4% compounded daily. Find the compound interest deposit will earn in 3 years. So, start with our formula. A equals P times 1 plus r divided by n raised to the nt. So our principal is $1,200. Multiplying that by 1 plus our rate, 4% change to a decimal is 0.04 divided by our n. It's compounded daily. So daily is 365 times a year. So we're going to divide it by 365 and raise it to the 365 times t. T is years, and we have 3 years. So we need to calculate 365 times 3. That's going to give us 1,095. And then we're going to take 0.04 and divide it by 365. And our calculator is going to give us a crazy decimal that gives us an e to the negative 4. So this is a really, really tiny decimal. So in your calculator, it's going to look like this. 1.095, continuing on and on and on, and it's going to show an e negative 4. So this is a tiny, tiny decimal. So we're just going to leave our calculator as is. And we're going to hit +1. So now, when we do that, we are going to get 1.0001095. Now, we can take that and raise it. Actually, take that and bring down everything else. And now in our calculator, we're going to take 1,200 times that decimal, 1.0001095, and then raise it to the 1095. And we get $1,352.99. So that is your lesson today. Please reach out if you have any questions dealing with savings accounts or calculating any of the interest dealing with savings accounts. Have a fantastic day.